Beautiful people, welcome to another video. Let's take a look at the problem we have for your viewing pleasure today. We have this problem involving exponent and logarithm. S raised to the power of log to base 2 of the argument x all upon x squared equal to 8. One may be tempted to use the division rule of exponents, especially on the left hand side, but that's going to complicate the solution to this problem. Rather, we'll get rid of the s squared here and involve logarithm. So if I multiply both sides of this equation by s squared, which is the least common denominator, we are going to be having s raised to log to base 2 of the argument s equal to 8s squared. Okay? Now, I shall then take the log of the base of 2 on both sides. So we are going to be having log to the base of 2 of s raised to log to the base of 2 of the argument x. Okay, let me take this up a bit. Then on the right side, we'll be having log to the base of 2 of the argument 8s squared. So as you can see, 8s squared becomes the argument when we take log to base 2 here. Then on the left side, as you can see, log to base 2 of the argument x raised to log to base 2 of the argument x. We shall then involve the power rule of logarithm. If I have log to the base of a of the argument m raised to the power of n can become a multiplier. So we are going to be having n log to the base of a of the argument n. Then again, I think this is the power rule of logarithm. Then again, we still have the multiplication law of logarithm, log to the base of a of the argument bc. I can split this as log to the base of a of the argument b plus log to the base of a of the argument c. So with these two intricate laws of logarithm, we shall then refine this problem. So on the left, log to the base of 2 of the argument x, as indicated here, is the exponent to this argument x. So I can then write log to the base of 2 of the argument x multiply log to base 2 of the argument x. Then on the right hand side, I shall split it with this multiplication slash the addition rule of logarithm. You are going to be having log to base 2 of the argument 8 plus log to base 2 of the argument s squared. So on the left side, log to base 2 of the argument x multiply log to base 2 of the argument x. That will give us log to base 2 of the argument x whole squared. On the right side, because it is 2 cubed, I can then write log to base 2 of the argument 2 cubed. Then plus log to base 2 of the argument s squared. Again, on the right side, I shall also employ the power rule of logarithm, as you can see here. I think we should come to the right side. So, log to the base of 2 of the argument x whole squared will be equal to 3 becomes a multiplier here. 3 multiply log to the base of 2 of the argument 2 plus 2 becomes a multiplier here. That becomes 2. Okay, that will be log to base 2 of the argument x. Now, log to the base of a of the argument a is equal to 1. This is also a theorem in logarithm. So, like I would say, log to the base of the same argument is always equal to 1. So, log to base 2 of the argument 2 is 1. We shall then have log to base 2 of the argument x whole squared equal to 3 plus 2 log to base 2 of the argument x. Now, at this level, I shall then make a substitution. I will say let y equal to log to base 2 of the argument x. So on the left-hand side, I'm going to be having y squared equal to 3 plus 2y. So this is a quadratic equation. If I rearrange this in a standard form, we're going to be having y squared minus 2y minus 3 equal to 0. So this is a simple quadratic that can be factorized. So we're going to be having y, okay? I'm actually factorizing two factors of negative 3 that can be added to give negative 2. That should be 1 and negative 3. So that will be y plus 1, y minus 3 equal to 0. Okay, as you can see, this is quite very interesting. So from the zero product property, it implies that y plus 1 equal to 0 or y minus 3 equal to 0. Upon whence, we can have that y equal to negative 1 if I subtract 1 from both sides, or y equal to 3 if I add 3 to both sides. Then we are not done. We had a substitution here, y is equal to log to base 2 of the argument x. So I'll say recall y equal to log to base 2 of the argument x. So when y is equal to negative 1, we're then going to be having log to base 2 of the argument x equal to negative 1. Then I shall transform this logarithmic equation to its exponential version. So I will take the base, I'll take the base here raised to the exponent negative 1. So we're going to be having s equal to 2 to the power of negative 1. From the inverse law of indices, this is something as 1 upon 2. So that's our first solution. Then for the second value of y, which is 3, we're then going to be having log to base 2 of the argument s equal to 3. If I also transform this logarithmic equation into its exponential version, we are going to be having s equal to 2 cubed. And that's going to give us 8. Now, so we have two values for x, s equal to 1 upon 2 and s equal to 8. So we shall test for extraneous solution or for foreign solution. I will record the main problem. We have s to the log to base 2 of the argument x, okay, which is equal to 8s squared. You know, what I've just done here is very simple. No need to write divided by s squared. So this form and the original are actually the same. So when s is equal to half, we are going to be having half raised to log to base 2 of the argument half. Is it going to be equal to 8 multiplied by half squared? So we shall test to conclude. So here, now our duty is to make sure that the base of this logarithm is the same with the base of the, of 1 over 2. You know, the base of the logarithm is 2. We have to make the base of the logarithm the same thing as the base of the exponent. I think that's a better way to say it. So, half is 2 to the negative 1. 2 to the negative 1. Or to the power of log to base 2 of 2 to the negative 1. Is it going to be equal to 8 times 1 over 4, which I guess should be 2. So, we have 2 to the negative 1, then multiply negative 1 log to base 2 of the argument 2. So as you can see here, guys, we are making giant stride. Is it going to be equal to 2, which is on the right hand side? So negative 1 multiply negative 1, that's going to give us a 1. We're going to be having 2 raised to log to base 2 of the argument 2. Now, log to base 2 of the argument 2 is 1. 2 can cancel out log to base 2 because exponents and logarithm are inverse mathematical functions. So the left hand side is actually 2, which agrees with the right hand side. So s equal to 1 upon 2 is a valid solution. So again, let's also test when s is equal to 3. No, sorry, come over, I started. When s equal to 8, we are then going to be having 8. Okay, that will be 8. Okay, raised to the power of log to base 2 of the argument 8. Will it be equal to 8 multiply 8 squared? Then again, 8 is 2 cubed. So we're then going to be having, okay, the fact is this. The left hand side is the major work. 8 is 2 cubed. All right, 2 cubed. Then we have log to base 2 of 2 cubed. Is it going to be equal to 2 cubed multiply 2 cubed all squared? So on the right side, we have 2 cubed, then we have 2 cubed squared. This is 2 cubed multiply. I'll use the power rule here. Okay, of exponent 3 multiplied to that will be 6 to the power of 6. So if I make do with the multiplication rule, it's going to give us 2 to the power of 9. So let's see if the left hand side will still give us that same value. So here, the power of this logarithm, we multiply this 3. So I can write 2 to the power of 3 multiply 3, then log to base 2 of the argument 2. Now, log to base 2 of the argument 2 is 1. So we are then going to be having, on the left side, I'm going to be having 2 to the power of 9 because 3 multiplied 3 is 9. And that is the exact same answer we have on the right hand side. What a solution and what an interesting problem. So guys, we are done with today's work. Please ensure you like this video and make sure you subscribe to this channel and smack that post notification so that you wouldn't miss out in our upcoming videos. See you next time and stay blessed.